Hey everybody, this is Scott Moore, and I wanted to take this opportunity to share a video with you of a Zoom session that I did with Paul Bruce of Neodis not long ago. I was actually working on this task, building out a document on how to set up a private instance of Neoload Web as a Kubernetes cluster. And to do that, I wanted to deploy it on the Amazon cloud using Amazon EKS. And so doing that, I actually created this, 30 plus page document that kind of takes you step by step through what you'll need to know to deploy something like this. And there are two reasons why you might put Neoload on EKS. The first one is to have a static cluster, which means we're going to deploy Neoload Web with containers that are always there, always running, and there's no need to auto scale them or anything. Then the second one would be to provision with Fargate a dynamic infrastructure with Neoload. That's actually a feature within Neoload that they offer where you can load up as many controllers and generators as needed during a test run dynamically and set this up so that you're only paying for the usage of this test infrastructure, this testing lab as you need it. So in this video, Paul talks a lot about building the dynamic infrastructure piece. So he talks about the feature of dynamic infrastructure. He also walks through building a cluster that uses a Fargate profile to connect and build up a Kubernetes cluster with an EKS. And so we don't get a whole lot into building Neoload Web. However, some of the same concepts of the AWS, the CLIs that are used, Helm, deploying a cluster, deploying a Helm chart, they're all part of this document as well. So I believe that you could learn something from it. So you'll know a lot about how to deploy EKS for both of these reasons. And these are not the only instructions. Neotis and Paul have provided this through GitHub repos as well. There's documentation there, and this was just my attempt to kind of help out, share what I've learned in building out a Kubernetes cluster, and I wanted to share that with you. So Paul also talks about some other features in Neoload that you may not have heard of before. He'll actually mention Neoload Compose, which is something kind of brand new. It's kind of a side project that he's working on. But I think you can benefit from this, and I hope you enjoy it. So let's get right into the video.
This is Paul Bruce with Neotis, talking with Scott more about how to set up dynamic infrastructure so that Neoload, when you run a test, it'll go out to some kind of elastic thing like EKS to provision the resources it needs to make the load on whatever system you're under test. So the first thing we want to take a look at is what does this look like in Neoload? It's a very simple thing to connect Neoload to an existing cluster, and we'll walk through what it takes to create a cluster. But from our purposes, Kubernetes is essentially a standard that helps you create a control plane that you can ask for resources from. That's all it is, right? Where do those resources come from? Magic sauce. We'll talk about that later. But the point is there's a standard place for us to interact with, such as something like the Kubernetes master, right? The control plane lead, where all it really takes is just what's the API to that cluster and what's the token, and in a way what namespace you want to put this stuff in. So detail for later. That's really all it takes to set up Neoload to be able to use a Kubernetes cluster. When you use it, what does it mean to use it? Well, obviously, we've now created sort of some settings somewhere, but what we really need to do is apply those settings in a place that makes sense. And so an example of that would be like this, where we've got this notion of a zone. When you run a test, you pick the zone that you want to run it in. The zone can either be physical, it can be project-based, it can be whatever you want. But the point is, this zone, for instance here, is connected to that EKS set of settings to connect to that Kubernetes cluster. We could have multiple zones for different teams connected to the same cluster. It's okay, right? Two different zones, that's fine. But the point is, a zone has some settings like, what's the size of the load generators and controllers that you want to spin up into that cluster. There's some presets and there's some custom. And if you've got some private, sort of like maybe Amazon ACR for the image repository, and you've got a private, version of what the controller and load generator should look like. Maybe you're layering in some complex SSL certs or some weird stuff like that. You can bake your own images, host them in your own um, image repository, and point to them from there. We do, by default, provide these images from Docker Hub, and we package them, verify them, harden them, make sure that they're working as expected, so that you don't have to go through that if you don't want to. So now that we've created a zone there, great. Now that simplifies the day-to-day testing. I can go into a test, maybe something that's already written. It's already got a project uploaded. I could just pick from which zone I want to run this, right? And in this case, we just happen to have a demo server that's got tons of zones. In your case, you might have some much smaller ones. So I'm going to look for something like Fargate, right? And then say I would like one load generator and a controller to be created to run the test. And then I hit the start button. So all of that talk about infrastructure providers, right? This is as simple as it takes to connect this stuff up, right?
Right.
It's just what's the Kubernetes master API? That's a standard thing. And what's the token for the service credential that is allowed to create containers in that cluster? That's all it really is. And then over in resources, you've got some zones. This is where you start to put the pedal to the metal about, okay, what does it really mean to spin it up? Right? We could have one cluster that's servicing two types of zones, one being a large zone and the other one being a small zone for like small testing. So that's where zone points to the settings that you want to use for your infrastructure provider like Kubernetes. And then in that zone, you specify what's the default like spin up properties, along with any kind of custom Docker images you want. Anyway, point is, on a test, it should be from a day-to-day perspective. If I want to go in and run a test, I provided a project, or maybe I already have the project provided. I select what scenario, and then I just pick from the list of zones the dynamic zone that I want, and then I press the start button, right? And I run. And it'll go out to Kubernetes and provision those containers for me, and then start the test. Those will be pre-licensed, ready to go, runs the test, spins them down for you. You don't have to think about zombie containers or oops, I didn't spin them up beforehand, or oops, I didn't spin them down afterwards, right? That's the whole point of our platform, is to provide a reliable logistics hub where you're just focusing on running your damn tests, right? Okay, so I kind of skipped over, this is just the product and how to configure it, but like I've skipped over the whole, how do I do this in AWS? Neoload. Okay, so I've got some examples here of essentially, given that you know a little bit about how to interact with AWS. For instance, you have AWS installed, like I do here, the CLI. We're going to be using a tool called EKS Cuddle. It's a specific control command line interface to interact with EKS. And EKS is obviously AWS's version of managed Kubernetes. So if I start with EKS Cuddle and I don't have AWS installed and logged in, EKS Cuddle is going to yell at me. So first thing we want to do is install AWS, and you can go look that up for yourself, such that you have version 2. It's important to have version 2.0 something of AWS. And secondly, you also need to do AWS configure one time only, so that you tell the AWS CLI who you are, right? So you would go out to your account details, your security credentials, and you would create a specific security token for yourself for this purpose. Or if you already have that installed, whoop-de-doo, right? But the point is, your configuration should be pre-configured, right? You should actually just make sure that you've done AWS configure, pasted in your details, and then on your machine now is capable of making API commands to AWS to do things like set up stacks, set up CloudFormation, set up the cluster. And that's what EKS Cuddle really helps you do. It simplifies, I don't know all the CloudFormation crap to set up a Kubernetes thing. Okay, well, fine. What do we need to know? Well, first off, then once you're done with AWS configure, you need to also have EKS Cuddle installed. And there's some instructions on eksctl.io of how to do that. On Macs, it's really simple. Brew install EKS Cuddle. On other machines, have at. So EKS Cuddle, right? The actual command you're going to use is something like EKS cuddle create cluster, but you need to provide it some of the details around how to create that cluster. And specifically for our purposes, AWS has something called Fargate, and Fargate is a native to AWS container native provisioning platform, meaning it's a service all by itself where you ask the service to create you containers like this, and it'll give it to you back. Well, Kubernetes can be configured to use Fargate as the way it gets containers, and thereby leaving the actual EKS cluster to not have any computers running around, right? You don't actually have computers underneath this thing. You pay for like a couple bucks a day to have an EKS cluster be available to you at any point in time, right? A front, almost like a facade on a building, but there's no building behind it, right? Until you ask it for resources. And when you connect it to Fargate, it reaches out transparently behind the scenes. It reaches out, asks Fargate to create containers for you, gives Kubernetes those containers, gives Neoload those containers. Neoload says, okay, I'm done with these. And then EKS tells Fargate, we're done with this. And it kills the containers. So with that in mind, we need to configure that cluster, that facade, and that's what we're doing here. So first thing is it needs a file with configuration. I've got an example one here. As you can see, it's a file. So let's just do it from scratch, right? We'll just copy this. We'll back up to our instructions. We'll create that somewhere local, right? So I'll just do something like touch Fargate, EKS cluster, something like that. And then I'll do VI EKS cluster. Oops, bear with me. There we go. I'll edit this. I'll just paste, I'll paste in. There's one or two things you might want to change. I've never had really great luck running on US East Region 1 because EKS, everybody uses that. It's kind of like the front door, the default for US, especially in the East. So what we need to do is actually create a cluster in some other region. And I'm going to call this one a special one. I'm going to call this Paul S. Bruce PSB test 1, right? So it'll name that cluster. There's a couple of other things about setting up EKS clusters. You don't have to use Fargate if you don't want to. You can actually set up static node groups, which are like EC2 images that are actually spun up as VMs, permanent, right? If you want a little bit more high performance, or if you just you don't want to use Fargate, you can set up an EKS cluster to not just be a facade, but to actually have dedicated nodes just sitting out there running, whether you have load on them or not. What I'm going to do is I'm going to create what's called a Fargate profile, and specifically anything that is asked for to be launched in the Kubernetes namespace of Neoload, coming soon, right? We'll talk about that in a second. It will specifically put those containers, it'll push that over to the Fargate profile that says, this is actually something I should do. So let's go ahead and save this. And now we're able to do the EKS cuddle cluster create. Or is it create cluster? I can never remember. Create cluster. And then F, and then point it to your file. Now, just like anything in Amazon, this takes time. This is not something you're going to be doing every test. It's not going to be something you're doing every day. This is a one-time situation where you're setting up the cluster, right? The facade. You're setting this up and putting this in your Amazon account under a particular region. What it's doing in the background, EKS Cuddle, this little command line utility, is doing a lot of the work for you. Not only is it monitoring the process, but it's also like, it's created in the background what's called a cloud formation script, the standard way to ask AWS to create various resources on your behalf. And there are quite a few resources that have to be set up in a proper way just to get a Kubernetes cluster work. You would, I don't think I know anybody who's even well versed at AWS that wants to, from scratch, make all the commands to cloud formation or to AWS just to wire all this stuff up. That's what EKS Cuddle does for you, right?
Right.
It does a lot of that configuration, and then it pushes that configuration as a standard cloud formation script. Now, the cool thing is, let's take a look at what it's doing on AWS. So it's in the process of creating a cluster. So let's take a look at the clusters. Oh, interesting. So I've got some clusters here already, but I've got this one, PSB test. This was the one that we named, right?
Mm-hmm.
And it takes the default version of Kubernetes. So it's the 1.17 is the most supportable, even though 1.19 is the latest version. This is what Amazon, kind of like when your phone doesn't give you the latest Android updates until like 3 months after Google ships them. It's because there's special fitting that Amazon needs to do to this to get it to just magically spin up the right things for you. So it's kind of their automatically provided service. That's the default that they have here. And if you look at it, it says creating, but really in the background, check this out. What it's done is it's created, it's using CloudFormation in the background to spin all this crap up. Look at this, it's creating process, right? So it's just using its standard model. Now, you could very easily, if you've got some security nerds, like I'm a performance nerd, security nerd or infrastructure nerd that really wants to know what the hell is going on here. Well, aside from the fact that EKS Cuddle is a Weaveworks application and it's used by millions of people around the world, so it's very transparent, it's open source. The fact is, like, if you really needed to figure out what the heck it's doing, and especially if your security people say, oh, well, the reason why this is failing is because you don't have a special policy that's automatically layered in, right? There's no automatic layering in. There are some advanced EKS Cuddle commands that help you set which policies you're using in order to run this stuff. But sometimes this will fail because your organization has explicitly required that there is specific security policies that have to be layered into your CloudFormation scripts or your asks to AWS before anything works. And that's just a security policy in some cases. So you can get the full, what is it doing, right? But the cool thing is these tools, these simple command line tools, dramatically simplify it. If you've got the right basic permissions in the AWS account, right, it dramatically simplifies the entire setup. And what you're seeing here is a bunch of events. Now, this takes about 10 minutes because freaking AWS. That's all I can say,
when you
right?
created this, can we go back to your local machine?
Yep.
So when you created this with this command and you used that file, how many items are in this cluster?
None.
No, it's none, but it's going to be completely dynamic as you kick off a test.
Correct.
Okay. I just didn't know if you had predefined a certain number in there.
Mm-mm. And that's the thing, the test itself, like the time where you need to define like how many things is actually in the test itself.
So where you define the load generators there as
right.
1 or 2, right?
That's right. You can say 5 or 10. Depends on the limits that you have in your Fargate profile. I think the limit is there's a certain set of limits, but you know, mileage varies depending on which AWS account you talk about, right? Which org. So the point is, if you want to put in 10 here because you see that your project is asking for 10,000 users, and you find that at 1,000 users, one medium size load generator works fine for you. Just you got to do your own calibration on your own scripts anyway. But you find the happy sort of average, which is kind of like, okay, well, for these type of web scripts, we can press a container in EKS to reliably do 1,000 or 2,000 or something like that.
Where do we define the size of the machine that the generator is, the resources that's being kicked off?
Remember, in a zone, remember how I said, you know, you can use the same infrastructure details for multiple zones.
That's where you choose it right there, the resource sizing.
Yeah,
okay.
you specify what the infrastructure provider is, and then you can say small or medium. But honestly, like 2 cores on a pod, right, on containers on a pod, Kubernetes usage of CPUs aren't like 0 to 100%. They're millis. They're, you know, fractions of CPUs. Mm-hmm. The point is, like, you would play around with this and calibrate. You might try with small and see how much you get, how much juice you get. You might try it on medium and see how much juice you get. And mileage varies. And the thing is, why don't we provide these? Is because even if we did provide them, half the time they would be wrong because
Right.
customers have different scripts.
That's right.
Customers have different requirements. So I hesitate to say, oh, on average, blah, blah, blah. We know that a little bit about our cloud, our Neotis cloud, the cloud credits and the large load generators there, because we tightly control exactly what infrastructure it runs on. But you could run not on EKS, you could run this on your own custom built Kubernetes cluster or your on-prem Kubernetes cluster, like Pivotal Cloud Foundry. And we wouldn't be able to provide what it does on that bare metal hardware with a cluster on top, right? Based on your configuration. It's just too arbitrary. So the easiest way to do is just spend like a couple hours doing calibrations, given
and then
your
just
script.
monitoring the generators inside of your dashboards and seeing where they start going off the rails.
Yeah, and that's the other thing, is that there was a conversation on LinkedIn this last week where somebody said, is it really good practice to like monitor your load infrastructure, meaning the controller and load generator that you use when you run a load test? Not just he was asking in general, not just Neotis specific. And JMeter doesn't necessarily provide that information by default. We
Right.
do, because we know, right? So any
Yes.
test you run has not just the metrics on the transactions you're running and the scripts you're running, but also provides full, complete transparency over what the CPU, memory, NetRAN disk of your infrastructure pieces are, right, in your different zones.
That's one of the first things I noticed about using Neoload when I first started. Was it was a given, it was a default, and it had the exact metrics I'm always going to be looking at, that I don't have to set that up externally, and real time saver. I use it all the time.
Yeah. So, this is taking its sweet long time, but it is progressing little bits at a time. It's doing what it's supposed to do. When we get to the point where we have a cluster, what EKS Cuddle will do is it will immediately then, you should also have kubectl, Kubernetes CLI installed on here as well. It will take the stack it just created and set your kubectl current context to this current cluster, which is nice because once this is done, then we'll be able to, if I open up a new tab here for a second, if we were to try to interrogate a Kubernetes cluster, right, like kind of looking at get events or a namespace, right, it has to be connected to a cluster, right? And currently I'm connected to config get contexts. Kubernetes kubectl, I just have a local alias for K for kubectl. But kubectl config get context shows you the different profiles. I've got a local Docker profile. I've got my my system under test I'm playing around with to play around with elastic load balancing and stuff. And I'm currently connected to that thing, right? So it's already set the US East kubectl context based on what I did over here. It's already set that context. So I should reasonably be able to say something like get cluster info, and that should tell me cluster info. That should tell me, hey, look, you're currently pointed to this new stack. Whether it's actually fully set up or not, it's something now you can work with, right? And so later on, once we start kicking off tests, once we get the proper output of this, we can now move on to the next steps of the setup. Over in my little setup here, it says the next step is to follow our normal instructions now that you have a basic cluster set up.
Okay.
So the next step here is to set up Helm instructions. Now I'm not going to run this until I know my Kubernetes cluster is fully set up properly, but Helm is a command line interface that allows you, similar to the way that something like apt-get or brew install or brew is a package manager. Think about different types of things you would want to do on a cluster as like packages of configuration. And so Helm charts are predefined things. Maybe your dev predefines it, or your infrastructure people, or Neotis has defined a simple Helm chart. to pre-configure this cluster to be ready to run load generators and controllers. It's
Right.
not that they're running right now, it's just that there's some basic things you need to do. And the most important thing that you need to do once you have Helm installed and you do a Helm repo, you basically connect kind of like a brew tap or apt-get repository, right?
Right.
You'd connect to our repository so that you can pull the next thing, which is the Helm chart that's specific to our infrastructure. And what this Helm chart really does is it basically just ensures that there's a service account called Neoload that is created in that Kubernetes cluster, and that there's a namespace named the same thing that you name your Helm chart deployment release. And for this, we'll just call it Neoload, right? And that'll create a namespace called Neoload, which is the same thing, remember, that we had in our YAML file when we look back over here. And we said, hey, by default, any workloads that this Kubernetes cluster is asked for that have a namespace of Neoload, please provision this on Fargate. Please use Fargate to provision that. And so we've created a namespace that has a Fargate profile so that we know that those workloads will go there. We also know that the Helm chart will create that service account in the and hook it up properly with that namespace. And then when we go over to Neoload and the one-time setup of this cluster, we go over to infrastructure providers and we see this, the namespace that anything that this Neoload infrastructure provider setting does, right? Multiple zones might use the same infrastructure provider. Those zones will launch those containers into this Neoload namespace. So without having this done, it might take just a few more minutes. But once we get this done, we'll be able to actually tail and see what is Kubernetes doing? What does Kubernetes think it's doing when we run a test,
Okay.
right?
So while we still got a little time, let me switch gears just a bit by
Yep,
saying this is for doing the dynamic infrastructure when we're running a
correct.
test to create the resources that we need. I've also talked about using EKS to stand up
Sure.
on-prem Neoload web instance. So that would be different in the sense that it's not dynamic infrastructure. We're actually just creating a cluster with static assets that are always running out there. How would this process differ?
Yep. So again, Neoload Web is not something you stand up and take down all the time. It's not like the load infrastructure where it's only when the test is running does it really need it. No, we need Neoload Web just like a hub, just like Dynatrace has its own on-premise hub, just like your Sonar Cube, those kind of things, just like Jenkins, right? Jenkins master doesn't get spun up and teared down every time somebody needs to do a test. It's a permanent asset that's there to be highly reliable as part of your testing process. So when we're talking about launching Neoload Web into, let's say, a Kubernetes cluster backed by Fargate or something, what we're talking about is a Helm chart that helps you set that up, given that you have a Kubernetes cluster. So you can have one Kubernetes cluster that's backed by Fargate that's solely devoted to just the on-off type models. And secondly, if you want to create a second cluster, whether it's backed by Fargate or backed by static nodes, right, like always on sort of EC2 images, um, that can be a second cluster, and you can actually launch Neoload Web and install, so to speak, Neoload Web into that Kubernetes cluster to always be available to run all the time. So there's setup instructions there to do that as well, and it's as simple, so to speak, as that, right?
And if I
Um,
think about this in just terms of like a diagram in my mind, I'm going to have two containers that are on, I guess, a single node, and that's going to have the front end and the back end containers, and they're going to talk to an external database provider, Mongo,
yep,
probably using Atlas, and that's just that the Atlas is going to have Mongo Atlas is going to have all your data in it, and then it's going to work with those two containers in that cluster. And I mean, unless you needed to, I mean, I can't think of anything else you would need to do to that cluster once you've got it set up and running. It's just there for you, and that's your interface.
right. Right. So let me back up for a second. And while we're waiting for this, let me show you a cluster that I have here. I have a system under test that is essentially launched on EKS Cuddle for that purpose. This cluster, unlike just being backed by Fargate, though I have a Fargate profile here ready to go, I also potentially have node groups, like static node groups, right? I can create a node group and I can do the same thing as what I was doing with the selector, where I was saying, if you want one cluster who's backed by static nodes, but also has a Fargate profile, you can deploy your on-off containers for load only through the Fargate profile, and you can deploy Neoload web with specific selectors based on a namespace to the static nodes. So you can have one cluster if you want to, but I would suggest putting Neoload web on not Fargate nodes, but on static nodes,
Yeah,
because
I would
you want the
agree.
performance to be high. You want it to always be available. You want it to be snappy, right? And so what's better than that, especially if you know this is a fixed cost, right? You don't know how many tests you're going to run, and you don't know how many containers you're going to need on any given day. That's what Elastic is good for. But if you know that you're running Neoload web all the time and it has to be available and it takes these type of resources, then why the heck not actually just pre-dedicate an EC2 instance, which ends up being a node in a node group to do that.
Okay. That's great. That's exactly what I was thinking. Now, I think you're about done on the other side,
Yep.
but before you do, there's one piece to this puzzle still that I want to make sure I have right in my mind. If you had all of this set up that we've just discussed, and all you wanted to do was take YAML files that were your scripts and put them into Neoload Web and run them directly from Neoload Web, or you were putting this in as like CI pipeline runs, that's fine. But there's still that component of creating scripts the normal way and creating projects that you would either export to Neoload Web,
You can do that.
or you may want to run with. So you still have to have Neoload GUI if you're going to create the traditional Neoload scripts, right? So you still
Especially
offset from that. You have to have that other virtual machine.
especially for tests that are not trivial, meaning just loading a web page. You load Amazon, there's like 200 different resources that are required on the page. There's no as code definition or no code-based load testing definition that will ever satisfy something like that, right?
Right.
Like even the most simplest and advanced from other tools, it would be like a 5,000 line script just
Right.
to load one page because you've got so many requests. That's
Right.
what Neoload GUI is great for, to visualize the complexity and to solve the problems of the end-to-end type tests. But when it comes to API stuff, right, there's a number of other ways to accomplish that in our ecosystem, the least of which is the thing I'm writing right now, which is Neoload Compose.
Right.
So Neoload Compose is a command line tool that allows you to essentially write scripts just specifically for API that can look as simple as this. So on a day-to-day, if you're trying to create a simple API test, it should be roughly a one-liner. It should be something like, hey, just make an HTTP call. But oh, by the way, since it's a performance test, I kind of need to know how long it's going to go. And I want to provide a ramp-up strategy for this. So if we just copy this and paste this onto the command line and we run this, oh, of course, I've spun down some resources in another zone. What it's done is it's created in the background the YAML, our code-based definition that's formatted in the way that our engine is ready to go to run. And in
Wow.
fact, you can actually do something like NLC validate.
That's amazing, Paul. I just that's amazing. And that's now what if that API call has to be authenticated? Is that a big deal?
Nope. Usually the authentication is because of some header, and you can add headers. There's a lot more advanced stuff in this. Like there's some examples here about adding headers. You can actually get your tokens from a file and shove them in there, right? If you've got a header that's called API token, or if you've got something like OAuth bearer tokens, the OAuth bearer token usually comes from a prior initializing request, and so that is just a correlation that looks like make this first command, make this first call, extract the token, and then make the second call. Now that we've got the cluster created we need to go back and read the freaking manual, follow the instructions, right? And the instructions that I'm talking about here are where are they? They're there. These ones, right? So we were back on this one, right? Now we're done creating the cluster. Now we want to continue with the Neoload's infrastructure setup. So first thing we would do is grab and make sure that Helm, obviously if Helm isn't installed, you want to do brew install Helm. And you add the repo here that kind of puts it in your Helm's knowledge about what repos to look for when you mention a specific chart. And so then the next step is that we do Helm install Neoload. What's nice about Helm is it not only can act on the cluster, but it can provide feedback, like for instance, instructions, next instructions. Okay, so what are the next instructions? What are we really trying to do here? Oh yeah, that's right. We're trying to figure out what in the heck to put in to this information. Okay, so what does it tell us to do? Number one, get the cluster info. Boom. Right? Okay, so it's the URL here. So let's create a new provider. We'll call this cluster, and we'll paste in that URL. The next step that it tells us to do is this fancy little get secret. And so we will paste that in there. Now the trick is, the way that kubectl works is it doesn't always give you the right line endings. So the trick is to start from the EY and end all the way at wherever your command prompt. Notice my command prompt is usually Paul's-MBP.
Right.
MVP. So I would end there and I would copy this whole secret into the token. And don't forget the namespace. What did we call it here when we launched this? We called it Neoload.
Yep.
So we want Neoload here. We'll apply this. And now we'll go over, and don't forget, we can't run a test yet until we've got a zone. So let's create a zone specifically for Scott's zone. Now, of course, we need to specify, hey, it's a dynamic one, and it'll load up the list of all the possible ones that we have. We're going to use these Scott's cluster settings and say, let's go with a small, and click apply. Great. Now we have a zone called Scott zone. Now we can go over to a test. And to your point, we can either upload it or grab it from the GUI, or we can do, Neoload itself. So let's take 2 load generators from Scott's zone. Let's point it to Scott's zone, and let's hit the run. So this is going to run for a couple of minutes. It's going to be very small test, but again, mileage varies. And what it's doing now is saying, when it says start dynamic infrastructure, it's going to take about 2 minutes, right? And especially on a completely cold Kubernetes cluster, what the heck's going on here, right? So what we want to do is kind of in the background, just for the sake of here right now, on a day-to-day basis, you don't have to do this. It's just kind of interrogating, what is this cluster doing, right? So we can go back. We don't have to look at AWS. We've now got, remember, k config get contexts. Our Kubernetes, our kubectl, I should use kubectl just to be very clear, right?
Why did you put Neoload in there?
Yeah, because I was all right. So our local Kubernetes like interrogator, our little CLI, is already trained on using that specific cluster. So we can start doing things like k-get namespaces. Oh, interesting, right? Namespaces. Now the new one is Neoload, right? Okay, so we know that things are working, but what's happening, right? And so what you'd want to do is something like k-get EV events, right? But of course, the default namespace, there's no default namespace, so you'd have to say n equals Neoload. So we can look inside to get the events for what's going on in that namespace. And so this is kind of the log of what's going on inside that namespace. You notice that it's created a pod for the controller. It's in the process of creating a pod for the load generator as well. It's creating a replica set that allows it to say replicas as two, to provide those two load generators using the native Kubernetes sort of language of how to ask for these things. And on the real back end, Kubernetes is just forwarding these things to Amazon to say, could you please do this for me, right?
Interesting.
So if we look at this, the way that Kubernetes is actually doing things, it's got a couple of different Fargate nodes that are satisfying us, right? They're actually behind the scenes doing this work for us. So this is just like, this is not equivalent to virtual machines. It ends up in your cloud billing as EKS usage and container usage, ECI usage. So with that in mind, let's go back and see. Oh, look at that. So it created that dynamic infrastructure. It locked the controller just like any other controller in the load generators. It's now in the controller context. It's leasing a license from Neoload web directly. And this can be your on-prem version of Neoload. So long as these containers can reach out to whatever you have as your host name, that's fine. So long as these containers have line of sight to the Kubernetes cluster or to the Neoload web server, it'll be able to grab this license, do what it has to do, and start running the test.